This is Miss Chilling. Welcome to Chapter 5, Trigonometric Ratios. He is the father of trigonometric. That means he invented this. Who is he? He is Hipparchus, and he was born 190 BC, which is about 2210 years ago, and he was a Greek. Have a look at this drawing. Wow, this is Hipparchus, and these are the equipments he was using. Look at the globe and look at this big round circle. What was he doing? He was very interested in observing the moon, the sun, and the stars. And he was able to obtain 850 stars positioned on this celestial globe. And with the invention of his solar and lunar theories, and also with trigonometry, he was able to develop a reliable method to predict when the solar eclipse is going to happen. Amazing, right? So he was a very famous astronomer, geographer, and also mathematician. Miss Chilling, do you think the theory invented 1,000 years ago is still applicable to the very modern life? Yes, I would say yes. The very fact that the theories can last for so many years until now, it means that it is still very practical, even until today. Let me show you how practical trigonometry is in estimating the height. As you know, it is very easy to measure the length on a flat ground, for example, distances. But it is very hard to estimate the height on a very tall thing, for example, a very tall tree, very tall building, super tall mountains. So trigonometry can help us, and it was invented 1,000 years ago. Super cool, right? Have a look at this tree. Now imagine you are standing here, and then you are able to measure the distance between the tree and yourself, which we measure it and we label this distance as S. Second, we are also able to find out the angle of elevation between the flat all the way to the top of the tree, and we label this angle as theta. With these two information, we are able to predict the height of the tree by using trigonometry and also by using the theorem Pythagoras. The angle that we need is theta and the distance of S. We plug it into the right angle triangle PQR, we are able to get that. Similarly, if you're going to measure a very tall building like a mosque here, we know that the distance between you yourself here and the mosque here is 100 feet. Together with the angle of elevation from the flat ground all the way to the top of the mosque is 79.9 degrees. From these two information, I'm going to predict the height of the mosque here. I also will be showing you this in the next coming slides. Before we dive straight into trigonometry, let's do some revision on triangle. Here's a triangle and there is a square here, so it is a right angle triangle. What else can we notice? Oh, there's an angle here, named X, and there's an angle here, named Y. In a triangle, I know that the total interior angles are 180 degrees, yes. First question, is this a polygon? What is a polygon? Polygon, poly means many, gon means angle. So polygon has a definition of it has to be 2D on a plane, and all the sides has to be straight, yes, and it has to be closed. Yes, this is a polygon. And is this a regular or irregular polygon? Regular means all my angles has to be the same. No, these angles are not the same because this is 90 degrees. Very obvious, X and Y have to be lesser than 90 degrees. So I would say it is an irregular polygon. How many sides are there? There are 1, 2, 3. So there are 3 sides and it is called a triangle. What type of triangle is this? As you observed earlier, there is a square here. Square represents 90 degrees, so it is a right angle triangle. What types of angle are x and y? Are they acute, obtuse, or reflex? What is acute? Oh, acute is lesser than 90 degrees. What is obtuse? Obtuse is more than 90 degrees and lesser than 180 degrees. And what is reflex? Reflex means more than 180 degrees but lesser than 360 degrees. So what do you think x and y are? I would say x plus y has to be 90 degrees. Therefore, x and y, they are acute angles. Make sense? Point out the vertices. Where are the vertices? So, this is one vertex, second vertex, third vertex. So there are 3 vertices altogether. Can you identify the longest side? How? If you go back to Form 1, by using theorem Pythagoras, we know that the longest side of a right angle triangle is the opposite of the 90 degree, which is PR, from P all the way to R. How do we get that? We get a 90 degree, and opposite the 90 degree is the longest side. 8. Name the longest side. PR is the longest side. 9. How can you calculate the longest side by using Pythagoras formula? I would say the hypotenuse, which is PR square equals to PQ square plus QR square. Next, name the angle of x. Besides knowing that this is x, I can also call it as angle of P, R, Q. Or the other way around, angle of Q, R, P. How can I write them? Angle of P, R, Q. Or angle of Q, R, P. Name the angle of y. The same thing from angle of Q, P, R. Angle of Q, P, R, or the other way around, angle of R, P, Q. Amazingly, you can notice if the angle is at P vertex, P has to be always in the middle. If the angle is at the R here, R vertex, and the angle has to be named, R has to be always in the middle. All good for the revision? Here, Hipparchus is going to show you how to identify 3 important things in trigonometry. First is a theta. Second, adjacent side. And third, opposite side. Trigonometry. Tri means 3. And gon means polygon, angles. So there are 3 angles. Make sense? And how about metric? Metric means measure. So there are 3 angles for you to measure. Exactly. Look at triangle of PQR, and we know that this is a right angle triangle due to the 90 degrees here. And according to Pythagoras, opposite the 90 degrees, the side here is labeled as hypotenuse, and hypotenuse is the longest side among all the sides in this triangle. How about Hipparchus? Hipparchus wants us to learn 3 things. Theta. Theta is an angle on any vertex. It could be here R or it could be here P, as long as it is not at the right angle here. So let's say my theta is here. The side besides the theta we call it as adjacent side. And the side opposite the theta, we call it as opposite side. For this triangle, first name the triangle. We have some labeling here, so very clear, we can know that this is a triangle of P, Q, R. Or it could be triangle of PRQ or triangle of QRP. Name the angle of X. For this angle of X, we can say that this is an angle of PRQ. How to see that? The angle here on this vertex has to be always in the middle. It could be also angle of QRP. They are both the same. Name the hypotenuse. Hypotenuse is always the side opposite the 90 degree, which is PR here. We can also put it as RP. They are the same. Name the adjacent side. Adjacent side is from Q all the way to R. So we can write that as QR or even RQ, the other way around. Name the opposite side. It is P to Q. So it's P to Q or Q to P. Look at a triangle here. What is the difference? The angle here is not labeled at vertex R. It is labeled at vertex P. So if my theta is labeled here as angle Y, so the side opposite of Y, we call it as opposite side. And the side next to Y, we call it as adjacent side. So for the triangle, the triangle name is triangle of PQR, triangle of PRQ, or triangle of RPQ. Name the angle of Y. Angle of Y is angle of RPQ. RPQ. Or it could be also angle of QPR, as long as P is in the middle. Name the hypotenuse, PR or RP. Name the adjacent side. It is from P all the way to Q or from Q all the way to P, QP or PQ. Name the opposite side, from Q to R, R to Q. So we can label as QR or RQ. That's all for the first part.